Hi everyone. Today we're going to be looking at an analysis of second degree functions, or in other words, quadratic functions. So, in your notebook, please put today's subtitle, Analysis of Second Degree Functions. As you may have already seen in the last chapter, a second degree function results in what we call a parabola. We're going to begin our analysis by first looking at the most basic parabola. The most basic parabola is represented by the following rule. Y equals x squared. Just a quick refresh on what basic means. The word basic means that we will be analyzing a parabola in its simplest or most natural state. And by natural state, I do not mean like an animal in the jungle. I mean that the parabola has not been stretched, flipped, or modified in any other way. Now, to complete our analysis, it's always important to have a graph in front of you so that you can look at it. So that's what we're going to do first. But in order to get a graph that's more or less accurate, it's always better to create a table of values first. So that's what we're going to do. I'd like you to take a moment in your notebook to prepare a table of values that's about this size. Go ahead, pause the video, and do it now. Okay, so let's fill in this table with some x's and some y's. So remember, your independent variable always goes on top. That's your x. Your dependent variable, the y, always goes on the bottom. So we're going to put our function y equals x squared. That's our most basic second degree function. Now I'm going to pick some random values for x. To keep life simple, I'm just going to use the following. How about minus 2, minus 1, 0, 1, and 2. These are pretty good values of x because there are some negative numbers, there are some positive numbers, and there's 0. Now, let's take each of them, plug them into our function, and see what we get for the y value. So when x is minus 2 all squared will give us 4. Next, when x is minus 1 all squared will give us positive 1. Next, when x is 0, 0 squared is 0. Next, when x is 1, the y value will be positive 1. And finally, when x is 2, the y value will be 2 squared, which is 4. Alright, now we have a good selection of 5 coordinates that we can use to hopefully give us a more or less decent parabola. So to draw your parabola, you're going to need a grid that's about this big. Go ahead, pause the video, and prepare your grid now. Okay, let's carefully put down all our points. So when x is minus 2, y is 4. When x is minus 1, y is 1. When x is 0, y is 0. When x is 1, y is 1. And when x is 2, y is 4. And do your best to draw a nice, decent parabola. There we go. Mine's actually pretty good. Alright, now that we have our parabola, it's much easier to look at it and conduct our analysis at the same time. So let's start with our domain and range. So please put domain. Okay, so refresher. Domain means how far left to how far right does a graph go. And since this is a parabola that never ends, the domain pretty much goes from negative infinity all the way to positive infinity. Or some of you may prefer to put R. Now the range. The range of a parabola is never from minus infinity to positive infinity. As you can see, our parabola has a low end to it, and sometimes it could have a high end if it was a sad face type of parabola. So in our particular case, for our basic parabola, the range is the following. if you look carefully, the range only starts as low as 0, but then, since there's no end to it, it goes as high as positive infinity. Next, let's identify our initial value and our zeros. If you look carefully, our initial value, where it cuts the y-axis, occurs at y equals 0. And for our zeros, again, if you look carefully at our basic parabola, it only cuts the x-axis at one location, at x equals 0. Next, let's identify the sign. Refresher. If a function is positive, you're looking for the chunks that are above the x-axis. And when it's negative, you are looking for the chunks of the graph that are below the x-axis. Let's do the positive sections first. So f is positive, which means bigger than or equal to 0, and let's identify our interval. Well, it's actually pretty easy for the basic parabola. The whole thing is on the positive side. That means it's positive in the interval minus infinity all the way to positive infinity. Now, the negative portions of the basic parabola is actually a little bit trickier than you might think. First, let's identify the part that is strictly negative, which means all the parts of the graph that are strictly less than 0, not including the 0. If you look at it carefully, there's no point of this graph that are less than 0. So we can simply say that this never occurs. Now, what if I didn't have the word strictly? What if I simply said, or f smaller than or equal to 0? That means the 0 must be included, because remember, the number 0 is technically considered a negative number. Now, there's only one spot where the function is y equals 0. It only occurs when x is 0. So this is why the basic parabola is a little tricky when you're talking about which parts are negative. Next, let's identify the variation of the basic parabola. Let's do the part that's sloping downwards first. So f with a down arrow. And if you look carefully at our basic parabola, the left part of it is the part that slopes downwards. And that begins at negative infinity and stops sloping downwards when x is 0. Now, when is it increasing? So f with an up arrow, in. Well, if you look carefully at the basic parabola, the right side is the one that's sloping upwards, and that starts at x equals 0 and keeps going to positive infinity. Now, when it comes to the parabola, there's actually two more pieces that you need to identify as part of its characteristics. So, let's look at the first of these two. The first definition is called the vertex of the parabola. And the vertex is very easy. The definition is that the vertex is the tip of the parabola. Now, if you take a look at our basic parabola very carefully, the tip occurs right over there. And when we want to identify the vertex, we want to identify its entire coordinate. So in the basic parabola, the vertex occurs at point 0, 0. So let's identify it. And the second definition for parabola is the following. It is the axis of symmetry. And the definition of that is actually pretty easy. It's the reflection line. And what is meant by reflection line? It's the line that cuts the parabola into two halves. So if we go back to our parabola, as you can see, the parabola has a left half and a right half. The axis of symmetry is the line that splits up the parabola into those two halves. And in this case, in the basic parabola, that line corresponds to the axis x equals 0. So let's identify that. And that's all there is to the analysis of a basic parabola.